a pineapple owl. I'm a pineapple owl. I'm a pineapple owl. I'm a pineapple owl.
Hello, everybody, and welcome. My name is Nathan. Otherwise known as Old Man Bills. We got Bernie here.
Hey,
What's up,
Boop,
Joe?
boop.
What's going on, guys? Little fun on the intro today.
and I'm Silent Bob. This is Nate, and we got Joe, right?
What's going on?
And already super chat. Thank you, Darren.
Thank you, Darren. Thank you,
Right
brother,
on,
man.
dude.
Darren's hooking us up again, man. Right on. Yeah, dude, I'm excited. We got a lot of Sean's stuff in here. Sean got out of his little mini surgery, man. He's doing well. And he sent us a whole bunch of stuff to check out.
And not just that, Sean, so generous, got us a microscope on its way to actually look at the samples that we're working with here. And today we will be looking at Sean's samples with the same microscope at his place. And wow, I think we got quasi crystals.
Yeah.
That's exciting.
Yeah, we got a whole bunch of good stuff, man. Some of the videos and stuff, Joe, are just cool. That he's got it like zoomed in, like right on it too.
Perfect.
Rav to
You know,
the next generation of understanding.
I love it.
Oh, Sean says he loves the song.
The pineapple owl.
Pineapple owl, pineapple owl.
Oh, we had to do it, man. Had to have a little fun.
Nah, that's the best.
All right.
I think we need some new emojis too. I think we need a pineapple owl. It's time to
Right?
update the stuff for the members. We'll talk about that. But anyway, I
What's
digress.
happening?
Right on. Okay. So show this real quick. So Sean's working with the salt in there, and he's hitting it with the round, and he's getting that growth that comes out of it. So let's see.
All right, I'm watching.
Right? Like literally, it's like watching living crystal just grow like a plant or like a fungus. You know, it's like it's alive.
Yeah,
That's just my alchemical take on the matter.
I mean, I truly do think that this fundamentally changes so many things that we probably just got wrong, you know, both about biology and geology.
And that life, spirit, and consciousness and creation essentially are what's in a theory of everything. It must be all inclusive. So when you lack those in modern academia, that's why you get stuck. I believe.
I agree. And, you know, that's right on topic for one thing that I was going to bring up today. And I have no idea how this had went over my head when I had initially seen it. But in Kaibalion, right? So that's all compilation and kind of straight to the point hermeticism, right? Kind of breaks down all of the primary stuff and gives it to you straight in the book, right? Well, there's a chapter on gender, okay? And at the time that this was written, I think it was like 1908, I want to say. Um, you know, they obviously were at a certain place in science, but the author that had written this had brought hermeticism into the energy and matter and energy interaction paradigm with it. And I was actually gonna maybe not right now but a little later on, I wanted to read a couple pages from it because it's super super interesting and it hits right on this crystal formation.
Nice.
Amazing, right? And that's what we're seeming to find is when you get to the boundaries of dimensions of space, time, matter, and energy, that there is this like, well, there's spiritual and potential God and whatnot, and everything at that level, that consciousness is a part of it, and thus any conscious being also is a part of that. So I look forward to that.
Yep.
Just want to quickly say shout out Dispatch Center, Paul there. See him in the chat. Got to meet him in person over the last couple of days, and shout out Dispatch Center.
Oh yeah. Well, I'd be remiss to say that we don't have a better promoter than Paul. You know, he's always out there preaching the word. So thank you, Paul.
Absolutely.
Absolutely.
Yeah.
Shout out Paul.
All right, man. Let's take a look at this. So I'll put it back up. So here's the structure he got when he was done.
Yeah.
It looks like a little chicken.
Right? Like a bird, some sort of creature. Legs, tail, feathers, a head, like so defined. That's like,
right.
wow.
The head looks like a snail, doesn't it? Right?
Right? Like life one way or another, whatever the interpretations, right? It's like I kind of see like a T-Rex baby bird man too, like, you know.
Yeah.
Wild stuff.
Well, I mean, the fact that he's able to form these, you know, first of all, what I find interesting is this, right? This isn't a crystal in its traditional form. Okay, this is the crystal that is macroscopically forming as if you drag the lattice structure from the edge. And that's why it's so light and fluffy like that. And that you could, because it's literally dragging the structuring up from the edge rather than have it build in, you know, at the molecular, just the molecular level. It's
I
building
get what you're saying with
greater like
that.
that. Yeah,
Absolutely. That's
right,
a great
right.
observation, Joe.
So, you know, just like everything else, right? We know that there's so much space in between how these things actually form. And you're just seeing that build out just like that.
And I love it because I grow very similar crystals, but with using very low to no voltage at all. And it's like anything in electrochemistry, it just happens at an exponentially slower rate. And you can just evidence of speeding it up by increasing the energy. And that's electrochemistry.
That's it. So it's like I've been saying the last few weeks, especially, it seems pretty evident now that the Earth actually works like the RAV. And it's in a constant state of energy exchange between the energies deep within the Earth and its electromagnetic field. You know, that's the other side of the energy. There's this exchange that's taking place all the time. And you know, at the upper surfaces is more the equilibrium points, you know, where where there's a diffuse zone between the two, and that's where they actually come together and interact. Ironically, that's also where we find matter. You know, we don't have any ability to dig beyond that, and all the stuff that gets pulled up is from those down low layers. Um, so I think it stands to reason that there's a very high possibility that, like, the mantle of the Earth is really just potential matter at that point. You know, it's in a form that it's not until it rises up, you know, and gives into the upper levels closer to the crust, that it actually structures into whatever element it's going to be. And what does that mean? Well, they want us to think that Earth was created and is comprised of whatever constituent matter was here in the first place. All right, that's what they want us to think.
Yeah, but it all seems converted, whether you're talking about trees, bushes, or rocks. It's all this, you know, converted from the energy of the earth itself.
Right. Well, I'm talking about like
and
matter
it's
itself.
water, right? Water and salt. That as soon as it gets to the ocean, it dissolves, and that the water cycle takes it to it, and you know that you don't need such high energy necessarily, or pressure or heat, or as much as just a little electric charge in that electrolyte that is the ocean.
I think more what I was getting at though was like elemental matter. Yeah. Right. So they try to make you think that you know, whatever, like for instance, Earth has X amount of gold X amount of silver, X amount of copper, X amount of iron. That's it, right? You can't have more than what is here according to how it goes. But what I'm kind of proposing is that it seems like if everything's working like the RAV, that if the mantle's in a state of potential and it's based off of the diffuse energy exchange, that means that there's no defined amount of any given element.
Agreed.
And then
Agreed.
the
It's
reason
all
that we
made
find
here. It's not from a
exactly
star somewhere else in another galaxy far,
right.
far
So,
away. It's coming
so here's
from
the
the
point.
inner earth of what's down there and how it's the cycle works and process
So
of it.
right. So what's something that we observe that suggests that that might be the case, right? Well, if we take into consideration that certain elements would only form at certain types of electromagnetic conditions, okay, certain electrical exchange uh, conditions, and what you end up looking at is large deposits of certain elements in very hyper specific locations. Okay, and they're spotted and dotted around the world. And oftentimes there's some type of correlation, whether it be latitude or prior latitudes. It- it's usually to do with the how far away from the pole you are, in relationship and the
And
meridian,
just
right?
specific conditions that happened in that one area that show that it was made there. It's like it didn't come blasting from a sun or an asteroid like this. It's like just common sense tells you it was formed in that like in that layer at that time or whatever
Yeah,
under the right condition.
right.
And yeah, it's
Right, right.
it's
So they say that if something hits the Earth and it's that large, right? Or so imagine all these impact events where all this elemental material deposition is occurring on Earth, right? They say that it sits there and clouds over and covers the entire Earth in a blanket. They say the same thing whenever you have a large volcanic eruption. That the material from the volcano actually will cover the entire planet, right? So what that would suggest is that we should have fairly even distribution of the elemental material then. Like fair, within reason.
exactly.
I mean, you could say, okay, well, it eroded away, it washed down with water. Water is the great sorter of things, etc. I mean, listen, I'm not a dumb guy, like I get these points, but you find elements in their natural like where that has not occurred. So it's like how do you explain it then? And I think that what I'm proposing is probably actually a good place to start.
Right on. Well,
Well
hold on
said.
real quick. I just want to mention Darren give out 5 Old Man's Builds memberships. Guys,
Awesome, man.
if you haven't got a membership yet, go up to the top where it's in the green and click on it and accept memberships right now and get yourself one of them. So I think honestly, Joe, you're right. This stuff is created as needed as the condition presents, and is deposited as the inner core or mantle moves around, and then more and more of it gets deposited.
Yep, that's what I'm thinking.
All right, I'm gonna just be setting up in the background a little bit, and then I'm gonna go out and try joining from my phone, Joe. Just because my computer, I didn't have a headset to work it right, and being in the same room, it's like be able to have Nate be able to speak better, and I'll be able to hear when I join back in from a cell phone here from
All right,
outside. So we'll see you guys in a minute.
sounds good, Bernie. Don't go far.
Yeah, I'll be back, man.
Yeah, there's some lag going on too on my end. I don't know why, but it's like the mouths aren't matching up and stuff today.
Oh, really?
Yeah, it's kind of tripping me out. I don't know if the viewers are getting that or not, but I certainly am.
Oh,
Oh
okay.
yeah, look at that. That's crazy. So that's salt is what we're dealing with at this point. At least
So
that's how it started out.
this is the glass tube. I think I should have played the video first. Let me find the video for you.
It's a great picture though, very high resolution. Yeah.
So I'm gonna make this bigger, Joe, but we can still talk. You can see it just patterning right in there.
Yes, you can.
And Sean says none of this works but just plasma. He has to create the RAB first.
I mean, that is the prerequisite. It's like I said all along. If it's acting as, the Maxwell's demon, and you need the sorting to occur in order for that to happen, means that you have to be stripping electrons in order to free up the atomic mass to be able. So you need the plasma in order to have the free atomic mass destruction.
Hmm? It's just so cool. It's definitely, I'll put back on the other picture, it's definitely fractal.
Oh yeah, I mean that's without saying.
It's so cool looking. Yeah, you can see all kinds of different things in there. I was just wondering how it sorts the pattern though.
Yeah, don't move that image. I'm going to zoom in on it. I want to see.
Okay.
I know if I would have done this ahead of time, I would have had a little bit better whatever. But it's wild because it actually kind of looks like its structure is like ice,
Yeah.
right? Yeah, it's pretty interesting. There's definitely repeating patterns that are recurring with the how it curves back into itself. It appears to be fractal. If I suppose, right, like if it started growing from it, let's look at the top one real quick, right?
Mhm.
It started growing from where it's at the most narrow at the bottom, right? It it looks like division that's spreading, right? So
Yeah.
it looks like it's getting proportionally larger. Then it has, like a collapse event, which it always does, and then it starts growing exponentially from there, collapse event, and then exponentially from there, collapse event. That's where you get your curvatures from. That's where you get your deviation in the width, where it kind of comes in at certain points and then goes back out readily. I mean, it's very fascinating. It follows the same principles as how I had explained previously. How electromagnetic fields build out a sphere. Basically, it goes into a state of diffusion until it reaches an equatorial plane, which is yet to be determined. It reaches a certain level of diffusion where the process basically collapses and reverses, and then starts going in its in the reverse manner by orders of magnitude, right? That's how it works. So it increases in the orders of magnitude and then decreases in orders of magnitude.
And that's where the fractal pattern comes from?
Yeah, I mean that's where the variation in the fractal pattern comes from when it expands and collapses and then starts to expand again. Yeah,
Hmm.
because it's growing out on the surface, you're seeing it in a two-dimensional plane. You know, if you
Gotcha.
were to bring the dimensionality out on it, you would actually see that it would have width to it as well.
Well, let's see. He's got some other pictures of it that are closer, I think. So we'll be able to take a look. Let me see.
Right.
This is another one he did. Just beautiful to look at. But what I noticed is he fills it up with water and it fights down the water. You, you know what I mean?
Mhm.
The orange keeps pushing down as it evaporates the water in the system. And at the top, he's got like a rab going on that's sculpting the glass itself.
Yeah, I see that. Wow, that's interesting. Weird.
Yeah, there's a lot going on here, man. I need to probably download this and zoom it in if I can.
Yeah, I mean, all of these tests are definitely, as far as how useful, it is. I think directly plays into the matter energy structuring. I think that this is definitely, like I said, depending on what you configure this as, is going to be most dependent as to what properties you're going to exploit and control.
Oh, check this out, Joe.
Yeah.
I don't know that you can see it, but I definitely can. Look at the bottom of it. Okay.
All right. You got to
I-
work a little slower though because there's lag on my screen. Okay, so when you get to the point you want to be, just stay so I could look.
okay. Sorry, I'm kind of moving around. Yeah, just give me a second. I want to make sure it's bright enough so you can see it. There's like little worm structures coming out of it. God, it's hard to catch it. Come on. Okay, I'm going to take a screenshot of this so we can really get a look at it. Because you remember how we had that ghost worm?
Yep.
That's what I'm seeing. But it's building out a little different. And it's weird because I know the cylinder is solid. Oh, come on.
So Sean is saying that when the raft forms in this configuration, that heats the glass directly beneath, um, the tube
Mm-hmm.
to 1,340 degrees Fahrenheit, which he says is sufficient to soften borosilicate glass. Um, and that it molds and reshapes the glass. I guess that's why you're seeing it at an angle. I mean, that's kind of interesting.
Yeah, the picture didn't come out too well. Damn.
I need to think about that one for a second, Sean, because the RAV and the temperature of the RAV has been one of those topics of conversation for a while. And obviously, if we're getting a high heat that's concentrated, and it's also there's obviously water in this experiment, right? So the water being present, that's going to restrict the whole entire thing to 212. So it'd be interesting to know how the end of that's heating to such a significantly higher temperature, and why that's not affecting the water in the tube, because I assume that the water in the tube it's not boiling and it's not a high volume. So at that type of temperature, I would presume that it would boil off.
Okay, Joe. You see this right here? This little thing that comes out?
Yes, I see that.
Okay, so this thing's a solid tube on the inside.
Hmm.
That's forming through the glass somehow. Like electricity through the glass. Like we're seeing a field coming out of it. And we'll go back to the video now that you recognize what it is I'm looking for.
Mhm.
Let's pull that video back up.
Okay,
Yeah.
and I'll zoom in. By the way, after this video, I'm gonna quit and come back in because the lag is so significant. I'm watching it on YouTube on my computer, and it's playing first,
Okay.
so that's not normal.
So you see one constantly at the bottom popping out?
I do see that? Yeah. Okay.
So we go back. So it gets really amplified towards the beginning.
Yeah. But let's replay this entire thing.
Okay, well, go ahead and come back real quick.
Okay, yep, I'll do that. Be right back.
Yeah, it's just interesting, guys. What I'm looking at is we're getting bursts that come out of it where the water is, but it's going right through structure, so it's got to be a field. It can't be just the water hitting some point or the water channeling. There's no way of that. That's solid glass, and you can see it inside with the high voltage striking everywhere. It's just interesting the way it's working, and it does it halfway up. It does it at the bottom. Yeah, we'll have to definitely zoom this thing in when we do the short video on it, so you guys can see it. But it's like dancing in there.
All
Go ahead,
right.
Joe.
All right, let's see. Say something so I know where we are. Okay, no, it's better now. Okay, perfect.
Nice. Okay, I'm gonna blow up the screen a bit. Okay, you can see it now.
I can.
I think it's just a field effect.
Yeah, I see that. Yeah, it's strange because where it's appears actually in the glass.
Yeah, it's going through solid matter. That's what I'm saying.
Yeah,
It's
I
got
see
to be a
that.
field.
Yeah. Uh-huh. That okay, so there is something else going on that I'm identifying. Okay, and it's interesting, and you're not wrong. Okay, but there is bubbling in the water. Okay, but it's hyper rapid. Okay, it's not a normal bubble rate, right? If you were just to boil something,
Mm-hmm.
and those bubbles are becoming ionized. And that's sort of what I think I'm seeing in that. But then, it throws the loop, right? Which is to actually penetrate the wall of the glass, which I'm actively looking at it doing.
Okay,
There's
so
an association with the blue arc.
yeah, so Sean says it's a glass tube inside of a glass tube. So we must be seeing the arcing between the inside and outside tube, is what he's trying to say.
In that case, then that must be, yeah, it's in the gap then at that point. So that would make sense. But I still see hyper rapid, what appears to be like ionization, a bubbling event or something.
Oh yeah.
Like whatever just happened with that little puff of steam was really strange. I'll tell you that. Like bottom right, there was like this little puff of steam that came up, but it was very, very abnormal how it moved. You might want to reverse it. Probably about 10, 15 seconds now. You want to see that.
Gotcha. Give me 1 second.
And is this footage sped up at all?
No, I think this is a normal
No,
thing.
okay. So you'll see that there's a little bit of maybe water on the lens or something. But wait when you see it starts to steam on the bottom right. And you'll see it doesn't emerge like normal steam would. I didn't see it again.
This is so cool looking. Yeah, I definitely have to slow it down and zoom it in. All right, we'll take a look at another one real quick. This is
Yep.
There you go, Joe. There you go. It's zoomed in now
Mm-hmm.
for the fractal.
Yeah. Well, what's interesting is that a lot of the previous dendritic type fractals that were forming, well, it was very consistent with what you would see in any type of dendrite and any type of like fractal set like that. This is a little bit more unique, because it's not working like a Lichtenberg burn, like dendritically like that. This is working out more as far as like crystal formation would be concerned. It would be called like botryoidally. Like if this were allowed to just grow upwards as well, this is the type of thing that would grow like little bubbles that would be wide at the bottom and then reach a termination at top, when the little bubble spheres,
Yeah.
sort of what you would see if you allowed that to grow just up like that.
So Sean did some research on it, Joe, and this is what he kind of came up with. So it sounds like what you're saying.
The glass labyrinth. Secondary interfacial instability at the micro scale. Yeah, so that actually does make a lot of sense, and that is exactly what I was describing. It's like a very, very small rapid bubble, and then it gets ionized. And honestly, whenever you ionize a bubble that's already in an intramedium, so you have a gas going through a liquid, that then exists as a plasmoid, rather than just a plasma. And that's exactly what they did and what they leveraged on the thunderstorm generator.
Okay.
Right? Was that intramedium, in order to hold the cavitation event to allow it to build in its capacitance.
Interesting.
Mm-hmm. Now, when those bubbles pop, you actually get a huge discharge of energy. And the energy is structured in a plasmoid. But the actual burst event is a large discharge of energy that occurs.
Well, then it goes more towards the water car and stuff like that, right?
Something to that effect. It's sort of like that. But it's not, but it's actual, it's not just like, a pressure difference, that's the energy output. It's, it's also electromagnetic in its nature. It's electrical.
Yeah. I was just fascinated by the picture, man. He's got this thing way zoomed in. You can
And the
see all the
pictures are very
bubbles.
good quality, high resolution, beautiful.
Yeah.
Artwork. That's like artwork right there. It's beautiful.
Yeah, let's take a look.
Yeah. But and you know what? You wouldn't get that rapid boiling, okay, from boiling. You would, however, get that rapid boiling from electrolysis.
Yeah, that's what Bernie's
Right,
saying.
because when you're releasing an abundance of hydrogen, the hydrogen's popping off a couple of molecules at a time, and then next thing you know, it's having a charge, becoming ionized. Now it's going to rise super, super fast because it's hydrogen and water, for crying out loud. There's a huge density differential that exists.
In the form it is right now that we're looking at it, it just looks like brain cell or brain mush when you see a brain.
It does. It looks like brain. It looks like intestines. It's following similar patterns to those types of formations this time around. Whereas dendrite type lattices are more attuned with like hard matter. So like I'm not saying like bone, for instance, would be dendritic. I'm not saying that, but the structure is more in line with hard hard matter as opposed to soft organic matter. That could be an indication of something. That could be an indication of animating the matter, and not in a life sense of the way, but anytime matter contains energy in a way that the matter has dominion over the energy, right? And it's able to control it. That's sort of the difference, between like a soft tissue and a hard one.
Gotcha.
Yeah.
We can actually see the tube inside the tube here on this one, Joe.
Yep, I can see that clear as day now. So that's definitely where it was, because it was in that gap.
Yeah.
It's very nicely spaced, though, Sean. I'll tell you that, because it just looks like a solid glass wall the way that you had it configured.
Yeah. That's what I was thinking it was. That's why I was tripping so hard. It's like, how's it going right through it, all of it?
And it looks like, based on this, it looks like the formation of the stuff is happening in between the two glass pieces, if I'm not mistaken. Or is it in the inside? It looks like it's on the outside of that inner tube.
Well, hold on. Let's go back to the last one then. It looks like the inside of the primary tube is where all the action is, where the water is, and where the anode and cathode are.
Okay, so that's where the deposition is taking place?
Yeah, because on the left-hand side, on the upper left, you see where the pattern is, and on the outside edge, there's no distortion.
Yeah,
So
okay. Yeah, it doesn't, it's a sharp edge. That's a good observation.
So it's got to be on the inside of that.
That looks like a pretty small diameter glass tube. So, obviously these are very thin layers, which makes it all the crazier to observe the complexity of such a nominal amount of deposit.
Yeah.
It's pretty incredible to see that.
So here's what he says about it: vortex-like growth pattern. Let's see. Transparent and molten glass. Okay. Shear and thermal flow aggregation. Is that right? Glass vortex. Okay.
Well, what's the context of this? Because he said that it was softening up the glass at the bottom. Is this the result of that softening glass?
See, I'm not sure. See,
I don't know the context of this.
Yeah, well, I thought it had to do with because it was right next to this, but it looks like it may be doing that in the center where the black dot is, but not the rest of it.
Well, he was saying the bottom of the tube was what was getting hot and melting the glass. That's not the bottom of the tube. And the bottom of the tube, you can see in the video, where it's like kind of tipped over a little bit, which I thought was an indication of melt. I mean, I could be wrong about that. I'm assuming a lot of things, but I'm just trying to make sense of what's going on here.
He says it's the center of the labyrinth.
At the center of it, you get that vortex of glass.
Yeah.
Or is that he's saying that this is the center of the labyrinth? This is what I'm saying. I mean, it's hard to make sense of this without knowing the info. So I know we're kind of feeding it to us real time, but
I think it's a center post because I don't see it in the rest of the glass. I see the bubbles and everything because we zoom those in. In the center right there, the black part looks like it's forming that thing.
Oh, okay, so that's what you're saying. That's what he's saying too, saying that the glass vortices form in the center of the labyrinth.
Yeah.
So are there pictures of the glass vortices from the center of the labyrinth then? Yes. Or was that diagram wasn't an actual picture of it, right?
It looks like a picture of one that's similar but not his.
Similar but not his. Okay.
So, which would make sense compared to if you're trying to make sense of how your stuff's looking, it looks like the center of it, yeah.
Well, all of a sudden, it starts to make a lot of sense too, because where the exchanges occur and how they occur, there's a couple of different things that would run inside and outside the tube. And it's like a whether or not it likes it sort of deal. And then you take into consideration that the RAV has the transaxial component that we often see. And then that would affect the center, so you have all the magnetic field effects, the external magnetic field effects of the RAV, and it's sucking inward, you know. But even though it's rotationally with it, like inside the tube, that creates an inner pull, and it appears then that would be transverse, right? Transverse of the axial spin would be the rotation of that pull.
Yeah. Okay.
He said, "There it is."
Oh, I see the upper one right in the center. You can see it. You can see the swirl.
Okay.
Yeah, I see. It's like a landmass, and in the center, it just popped up. That's cool.
Now, where is the RAV in relationship to that? Like, where does the RAV form in relationship to that?
Okay, so hold on. Let me play the video you can watch. It looks like it's etching it on the outside, but then there's always a consistent part to the middle.
Well, this for a Sean RAV, this RAV is antsy.
Yeah.
It's not wanting to, Well, there it goes. Now it's thinking about doing its thing. Not as stable as usual, though.
Yeah, it's cool, man.
Yeah. I mean, this thing is moving in a counterclockwise bias. If you see it's in its agitation, it's significantly predisposed to move counterclockwise. Not saying that it won't go the other way, but it seems like the majority of the time it's sort of always reaching in that one direction.
Yeah, all right. So those are the ones you sent me today, Joe.
I mean, that's really cool. Definitely need a little bit what's going on to really get to the bottom of it. But all the patterning is very familiar.
Absolutely.
Very familiar for the stuff we talk about. Familiar for crystal formations. Familiar. Honestly, these ones are looking more like organic matter. Like organic formation. When it starts to do that wiggle line thing. It's like less crystal in its form and more organic. It's probably because it's made up of more than just an elemental material. It's probably made up of some kind well, you said there's salt involved. So right there, you're dealing with a compound. So if you're not tearing that compound entirely apart, then it's gonna be structuring based on the sodium chloride as opposed to with probably also because of the water element, probably going into hydrides also, so it could be you're forming different hydride formations.
Yeah. Let me pull up another one for you, Joe.
Steven's saying, so Sean, maybe we could put your electorate into Roman concrete column with a Bendini collector coil at the bottom. We could make some hydroxyapatite. We could mix some hydroxyapatite into the mix. So hydroxyapatite is actually a calcium mineral, right? And it's also piezoelectric, as far as I know.
Yeah. Well, it makes sense. Roman concrete had crystal in it so that it could repair itself. And it had a lot of lattice structure in there. Closest thing to graphene that they can get was the lava, or not lava, but the volcano when it blows up, the ash.
Mm-hmm.
So, yeah, that was one of the things in there that made that Roman concrete good.
Yeah, lots of lime, soda ash, and
Yeah.
the stuff was self-healing, because the way that they mixed it back in the day, the acid rain would actually, eat it up a little tiny bit, enough for it to precipitate into the cracks, any cracks that formed. And then because, it'd be bonding as it dripped down with all, the both sides, basically nucleating the lime out of solution, right? And
Yeah.
it's depositing it behind it as it drips through, so literally healing itself.
Huh.
Pretty incredible. That they, I it's hard to say. Was that just a byproduct of their process, and they're like, oh look, it's got this great function and feature, right? Or did they make it one way and then say, oh, but if we do this, it actually heals itself? Like, did they figure it out? Like, I mean, it's hard to say.
Yeah. Well, it looks like they knew something more than we did, that's for sure. And the fact that it does do it was just amazing. I didn't realize that until just recently.
Oh yeah. Well, they spent a lot of time and money and research and development over the course of hundreds of years, to figure out how to try to get concrete not to erode with acid rain, or rain in general that's mildly acidic, I should say, even, right? So
Yeah.
it's, they try to take that out of the equation, only for the shit to all crack and crumble over time. So, oops.
Huh. Wow. Should have paid attention. All right. Hold on. Let's see. Oh, I wanted to show you this one. Look at the colors going on there.
Oh yeah. I could tell that's that color that we talk about, man, where it's like white as white could be, but gold at the same time. Oh,
Hmm.
and every color in the rainbow within the gold. It's crazy.
Yeah.
Yeah. You can see the spectrums that it's hitting. It's hitting both the infrared and the ultraviolet spectrum simultaneously.
Yeah. That's what
You
I
know,
thought.
it's hitting both spectrums simultaneously, but coherently, right? So it's actually putting out coherent light in those bands, and they're overlapping. And that's actually why it looks gray in some spots, you know? That's because you're putting out both spectrums.
Yeah, I thought pretty blue, man. Come out real nice.
Yeah, it's blue, but it's red underneath. I mean, I'll tell you what, that's a screenshot worth saving for right now. Take a look at that one later. You can actually see the patterning inside the light emission. It's banded, but it's also segmented in the bands. And if you look, it's actually it's north, south, east, west, and then the sub, the sub directions, northeast, southeast,
Yeah, I
right
can
in
see that.
between. That's how that's broken out. Like the
See,
cross with the X through it, like Jesus.
oh, it's funny you mentioned that, Joe. So I did a video on that one. Let me show people that. So I showed them the cross on the top. Remember we saw the black light in there and how it's doing that, and then you see the green in here on the portrait of Jesus here, and then you see the directional. So when you see this, there's the lens that goes across it, and it's through one of the bubble things that you always see. But then it goes down and hits a point, and it starts another one. But then you look over here at his hand, on his right hand, it goes down. It does the same thing. It has like a lensing part, and it
Yep.
shows you the light goes straight to the center and then builds out on another one. And then it shows the blue, and it's all fractal in nature. at the bottom one.
Hmm.
It's like the light spectrum, and it's like everything that they show in these portraits has a meaning to it, and it's all kind of being revealed because it's all part of
Well,
light.
well, this is crazy speculation, but where Jesus is holding the compass in his hand, right?
Yeah.
He's got the middle pin to center at 90 degrees up, right? So you could get the angle that he's holding it at, and if I'm looking at it right, it's probably somewhere around that 40-degree mark in there,
Absolutely.
where it's hitting. And if I'm kind of thinking about looking at Earth like dead on with that pointed to the right, right? I mean, you could well be either pinning that on, that's either pinned on Jerusalem or Giza or somewhere right there. You know what I mean? It's right
Or
that line there.
you could even say it's the refraction pattern. When light hits it hits that lens, it shoots out. You
Mhm.
know what I mean? That might be the angle in which it's pushing out, which would be even more interesting.
Right, right. That's the relative angular relationship potentially. I don't disagree. I mean, we see that the Rav spins on an off canter axis, right?
Hmm.
And that again, that's all relative to the fields that are ambient.
I just find it interesting, man, and I put it out there for everybody because this is the way I see it. You know what I mean? That when you say, we're children of the light, God is the light. That's what I'm seeing. It's a scientifically proven thing that once you understand plasma physics, you understand how the light works, and you understand why it would be said. And it,
Now, another thing, by the way, about where the compass is pointing is, it looks like it's on like the tropic like line right there. And what's interesting to understand about these different lines that we have, like the polar line, the tropic line, and then the equator, and then in the inverse on the southern hemisphere. Well, it's you got to remember spheres grow out by again orders of magnitude, right? So every single time you go past one of these thresholds, right, there's a significant gain in landmass and degree,
oh yeah,
like of curvature, right? Even though the curvature is consistent, right? The if you're looking at it as a from a side angle, right? It's like you're gaining all of that land mass. So the amount of land goes up exponentially as you go down. And what you end up realizing is that when you hit like the tropic, for instance, even though as a straight line driving, for instance, right, from the
hmm
tropic to the equator is a less distance than from the tropic to the polar line. Well, your landmass probably I don't I'm just making numbers up here. The landmass north of the tropic versus south of the tropic to the equator, okay, could likely be like this equal, even though it's a much shorter distance, or greater, just because of the diameter difference.
hmm.
So it again, it has to do with proportions, right?
Hmm.
And relationship to the North Pole.
Oh, I gotta show you another one. Hold on, I'm trying to find a good one for you, Joe. Um, oh, this one cracks me up. Okay, you know how they say it's a camera effect all the time?
Mhm.
And you notice this camera's not moving a whole lot, moving a little bit, but that thing's moving, right? So here it comes, where it's like a bait and switch on you. Everybody's gonna go camera effect, and then until it does, come on, until he shows you this. Now watch where it spins. You seeing it?
Yes, I am.
There's no camera in the world that does that.
No, nope.
There,
That's not how lens. That's not how lens flares work.
So you can see it. I'll try to find a good spot for you. But you can see a little down on the bottom, right where the flat part is. You
Yep.
could see the little pink right there, and it has a little dot in the center.
Mm-hmm.
And you can see it rotate as he rotates the entire thing. So let me go back to it. Yeah, it picked a spot and it rotates onto it.
That's awesome. I'm gonna have to break that down. Things don't do that, Nathan. Things don't do that. Things don't do that. Also, how come it's moving three dimensionally? Because because of the holographic projection.
Dude,
Play that one more time. Play that one more time.
It's so worth it. Look at that.
Yo, no. That's ridiculous. Nice spark gap, bro.
Yeah.
Some people are fucking idiots.
Oh. Dude, I just love it because it's like right in your face and you can't avoid it because you like. Well, I love the build up to it because it looks like it's, hey, I'm just moving the camera. It's shaky, right? And then you really get down to what he's doing and you look at it and you're like, oh, that isn't right.
Yeah.
It's just moving.
Yeah, it's spinning physically on the table.
Yes.
Because it's got a location.
And that camera, dude, that camera can't be any straighter. Okay?
No, it's not moving. The camera's not moving.
That's what I'm saying.
Yeah, well, that's because we know what it is, and we've known what it is. And when I discovered what it was, I felt like there's no way that I could propose that this is what it is confidently. You know what I mean? Because it sounds so batshit crazy, but like, how many times are we just gonna have examples that show it exactly? You know, and still what, leave it up to but it's not, you know, like, no. That is ridiculous. It's a ghost, man.
Dude, Sean nailed it right there. Like, I had to look at this like 5 or 6 times, Joe, and I finally picked it up. I'm like, what is he showing me? And then I looked at it and I go, dude, that's insane.
It's also, by the way, there's a mark on the plate that it's related to.
Oh yeah.
Run it again.
Okay.
One more time. I see a mark where it's kind of fixed at. It moves, but
it's not necessarily fixed. It's going inside the triangle.
No, it's not fixed.
It depends on his rotational speed. Watch, he speeds it up and slows it down.
Yeah, this is going to be one of those, I need to break this thing down. So make sure that I have this video. I'm sure you sent it to me, but make sure I have it.
It pulls further out the faster that he spins it, and then it'll go back to the center.
Yeah, it does.
Yeah. So you if you watch for that every time he starts to spin it real fast, like right here.
Yeah, then it lifts. It actually lifts up.
Yeah. That's interesting.
That's all right there.
Yeah.
That was that little jump. It reminded me of how I described that parabolic magnetic sweeping that occurs before it spears out and pinches off. Right? Like, because you saw how it like went up and turned and then went down. It was like, and it was rotational too because it was spinning, right? So it went like, woo. Very cool. Very, very cool.
Yeah.
Just when you think you've seen it all, you know?
No,
never seen it all.
No, not from Sean. Sean's got to keep guessing every time.
Yeah, that's it.
Okay, so hold on. I want to show Sean that he told me that I need to start putting arrows on things. So I did it for him. where it's showing the factor growth. Now, every time I asked AI about this, they said, "Oh, this takes hours to do." This literally looks like it takes seconds to do.
Well, so that's what I was saying before about changing the paradigm of geology and all this stuff. Is they'll tell you stuff like, "Oh, this crystal is 500 million years old, and it took maybe 1 or 2 million years to form."
Yeah, that's what they say.
I don't know that I buy that as far as you could throw it.
Not from
Like,
watching this.
no, and also, like, not to mention, they make huge crystals in laboratories. It ain't taking tens of thousands of years. They're making them every day.
Yes,
You know,
takes them like 5 days, and they got a crystal.
right? So something that they've harnessed could make it, within minutes, except or hours or days, let's say, right? But they propose that with the energy, weight, pressures, etc. of Earth, that somehow it would take billions of years. Like what? Like, do they hear themselves sometimes?
Yeah, I
Like,
don't. I think it's their best guess. Yeah, but you can see it growing on top too. So if you look right up top, it's growing up there. I should have put another arrow, but it's just interesting. So shout out
Well,
Sean for
hey,
pointing
for
things
what it's
out.
worth, maybe it is taking years, except you screwed the time dilation out up so bad in that immediate area that, like, that's exactly how long is passing. Like, who's to say?
So okay. Oh my God, dude, this brings up another subject. They were they found a field outside the Earth, right? That the what do they call that one that they sent out a long time ago? Um, Voyager 1. Sorry, I'm thinking
What?
Star Trek. Voyager. No, it's Voyager 1 and Voyager
Voyager
2.
1. Okay.
And then they sent them out and they said that they're reaching the end of our solar system. And what they're finding out is it seems like the fiery wall is what they're hitting. Okay. They were doing a video about it and I'm laughing because what if the RAV itself on the inside was hollow and you built out a sun and planets and everything else and you're finally getting to the RAV outer wall that's yellow that we always see? I mean, I know it's probably not probable, but if it's doing something like that, what if you're building and collapsing solar systems every time you're turning this thing on? Wouldn't that be wild?
Really would be, and even though it sounds absolutely crazy,
Yes.
it definitely isn't when you start realizing exactly what you're playing with here. It's you got to realize, like, even if you go with straight mainstream science, right?
Uh huh.
They say that entropy is times arrow. Well, what happens when you take the entropy and you start, reversing it, and changing the entropy in the exact area, where you start taking all the energy that is mixed together in a more equal state and you start pulling it apart. Well, all of a sudden, your time, its arrow must therefore change if entropy is the arrow of time, right? If you're reversing that entropy, well, what does that say about what you're doing in to the time dilation? It sounds like if you're reversing a process that is so-called mechanism of the arrow, it sounds like you're taking that arrow and you're kind of turning it the other way.
Yeah.
So, I mean,
I,
but that doesn't speed things up like I would have just supposed. It actually slows things down.
well, who knows inside that little mini solar system if you did build one out that wasn't like 2 billion years to them. But to us, it's few seconds.
Yep, that's true. Right, we're already growing microscopic things macroscopically.
Yeah.
So, again, now you've changed what's relative at that point because of
Yeah.
the scaling.
I just thought it was an interesting thought. Do I know any of that's true? Absolutely not. And it does sound about shit crazy, but I honestly think it's awesome to think about it as a thought experiment, at least.
I think it's a great thought experiment.
Yeah. Let's take a look at this. This one's my favorite out of all of them. So, can you guys see the dark mass building up on the upper right hand side?
Sure can.
Bring come in. I'll bring it back over here. Take a look at that. Every time the plasmoid on the bottom, the pink moves, the upper one on the right moves.
Oh, dude, Bertie, did you see this, dude?
Oh yeah, we were looking at this earlier, and it's like it's the antipode, essentially. It's like that dark light. Is that what dark matter or dark energy is? Brings up many questions.
It really does. Yeah. And by the way, that's your moon. When you're looking at stuff that's occulted, and you see that crescent moon, that's the parabolic field on the opposite side. That's just whoop, because it's always just a event horizon of light surrounded by complete dark. And you'll see that flash here repeatedly, and you see it in these patterns all the time. And they go in exactly the same sequences that you see in the symbolism,
Yeah,
And
I was showing Bernie the stuff carved in the rock. It's exactly the same. You can see it spread out on the bottom here, and it's the second picture down. All spread out on the bottom and open at the top, and you see in the center there's a circle. And I know you can't see it very well right here, but it mimics the way the wrap built out right here. It mimics the plasmoid versus a magnetic structure. So when we look at another solar system and we see black dots come across there, they say that they're the moon, or they say that, you know what I mean, it's a planet or something. How do they know it's not one of these dark spots?
yeah, just all that is what we talked about. There's these eddy currents that ride the outside of these magnetic fields of anything.
Well, again, though, if it, like you said, how do we know it's not that? Is that what dark matter could be then? And like, that's the missing link, or
so okay, so in my opinion, you're right, but there's more to it than just being that simple. And here's why. Because what I was just saying, right? So you have these eddy currents that ride the outside of these magnetic fields. These eddy currents serve as wells, right? And because the system is separating and bringing equilibrium in the center mass, these are not the center masses. Okay, so you have deposition of low energy, potential, matter, basically, and then high energy potential on the other side. Now the thing is that in these wells, it's also in a, right. I said potential, so it's not structured. It's not combined at all. It's with a whole bunch of itself, so it's not doing anything, right? Well, when it goes into that state of potential, it becomes what they like to call quantum, right? At that point. So then what ends up happening is that it's there, but because nothing opposite it is interacting with it, it is effectively not there. So it becomes dimensionally irrelevant, and inaccessible. It becomes out of phase. The thing is that the well in which it's held, so to speak, is partially here. Okay. So during times of excitation, meaning that there's an inequilibrium in the feed, it'll start feeding the other type of energy in, whether it's the low energy potential or high energy potential. Well, when it starts doing that, then that manifests that energy out of it and then feeds it to the source to maintain the equilibrium. So it doesn't actually, and it does so what they would consider quantumly. It tunnels out, basically shoots that, it emits that potential, and then it gets received, like through a transmission, where it's then manifest, at the central equilibrium point. In this case, it would be Earth. So it's very interesting how that works, I think. But this is exactly what they were talking about when they were talking about all these magnetic shearing components that occur, and they call it a flare arcade. Oh, you are the old man now. It's like you ate him or something.
I know, right? And so I've been given control for a minute to give a shout out to CBJ Wahoo Yahoo, and that he sent some awesome orgonite
Oh, look at
reactors
that.
to
That's
us,
cool.
and that they hook up to the frequency generator, and that they actually shoot little plasma out of yeah, buddy, CBK Yahoo. And yeah, so momentary here. Hold on, I gotta grab an X-Acto knife, and we'll do a live opening of the second package that he
Right
sent.
on. That's awesome.
Right on, right on, right on.
Hey, so while you do that, I'm gonna tell you about an experiment that I did recently that was actually successful. All right.
Yes, we love successful experiments.
And I could not record it because my phone was part of the equation. All right. So what I did was I had these packing blocks that came with something. I don't know what it came with, but I had saved them forever. Okay. And I piled these stacking blocks up in a way where they were alternating in the hexagonal structure. All right. And I taped them all together to fit, and I had a couple different configurations that you could have with like a central void, whatever. I didn't seal off, but I enclosed the void that I left in there, okay, to allow for a central resonance chamber. And then I placed the box configuration atop of a speaker, okay, and I was playing different tonal frequencies through it. And then I put a couple of different, rock specimens on top and stuff like that. And as it built in its capacitance of the sound through CME, because each one of those hexagonal chambers is acting as a resonance cavity, right? It's amplifying the sound exponentially. All right. And it starts to actually allow the rock to move. Now, you sit there and be like, well, it's a vibrational effect, dampening, et cetera, blah, blah, blah. And I'm not saying that there wasn't some of that going on. All right. But now here's where it gets weird. I I rigged up my handheld Tesla coil in a very, very insane and probably somewhat irresponsible way. Okay. And I started waving it like a wand, okay, with the brass rod down the center over the configuration, and all the rocks would start to follow the rod.
Okay. So that's like
Well,
Edley Scallon-ish almost.
yeah. So it was very, very, very cool. But CME is a real deal, man. And the amplification was out of control, but like just how the rocks and stuff were able to move so freely and doing so in sort of like a methodical way, I just found super fascinating.
That really is. I love that.
Yeah.
Okay, and so we have the full system that you then plug in, and then we'll have
Here, who wants to
lightning
see the
coming.
irresponsible Tesla coil setup? Look,
Okay. Oh
Intel
yeah.
Tesla coil, Rob.
Hold on. Let's do full screen for Mr. Joe. Joe, you're full
Yeah,
screen.
I'm coming. I'm right here.
All right, all
This
right.
might knock my phone out though because it throws out all sorts of interference.
Right? That's not one of the things people don't understand. Why do you get that on
You see
camera?
my
Why do you
lights
get that on
flipping out
camera?
already?
Right? Flipping, yeah. See, it's EM field, and oh yeah, look at that.
Messes your lights up real good.
And it's like just instant strobe light, pretty much, of the
Oh
rest
yeah.
of the room.
All right, let's see if I can put this piece of quartz on this book, and then I'll hit the quartz with it and see if it does anything. I'm not saying it will, because this is not any of the tests that I've done.
Right? This is live science, first time ever, people, happening now. And again, oh, I heard a zap. Yeah. This is live wizarding, people. Look at that wizard.
Oh,
Focusing the intent. You gotta
she's
lift it up
cooking.
higher, higher, higher. We gotta get camera. There we go. Bam. You can hear it.
Oh, it's freaking crackling through still, nonetheless.
Oh, we can hear
Not
it.
conductive, right?
Except for when it zaps. Oh, rub it the whole way. Yeah. This is as non-homo science as you can get, as we rub the shaft all the way along, trying to get a charge to shoot out the end.
Oh, well, my lights just went way the hell up. Oh, look, there's gold foil on my book. It's actually hitting the book. Look.
Oh, yeah.
Oh, and it looks
Right,
really cool when it's doing
Look
that,
at
too.
that, eh?
That ain't no joke.
That's the Cavalion.
Oh, that is rad. The whole okay, I might have to turn my lights off so you can see this.
Yes, please. We're going dark. Oh, look at it go. Woo! Now that's what we call charged alchemy right there.
All right. Hold on. I'll turn the other light off just for real good measure.
That's wild. Zapping the gold foil. What
Yeah,
a perfect book.
Move
Can
it
you
all
get
over.
Can you get more wizard than frying the Cavalion with plasma on gold foil? I think we're taking justice to a whole new level.
That's it. Doing stupid things one day at a time.
Doing stupid cool things. Oh, look at that. Everyone should have a book that does that. Hermetic philosophy that shoots lightning. Woohoo! That's so cool.
That is the correct geometries, isn't it?
Right? Exactly.
Square in the circle.
Look at that. Right in the center again. Oh, look at there. See? Bam.
Yo, I don't know. I'm very fascinated by that. That's cool.
Right? I know. Watching the distribution of it.
Oh, fuck.
Oh. Amazing. Watch where you are.
I don't know, man. Pretty fun. Not gonna lie.
I love it, and I don't think you can get. I think Harry Potter ain't got shit on you, Joe.
No, I don't think so.
I don't think so.
His wand shoots dud.
Right? Bam. The Cavalion. Charged.
That's it.
Charged Cavalion.
All right.
Love
Let's
it.
put the quartz back dead center of it and see if anything gives, man.
Okay. As long as we don't summon a demon, right? Only Archangel Michael coming out of that.
A lot of ozone. All right.
All right.
I'm gonna try one more thing just because I'm extra
full screen. Let's go
persistent.
for it.
Hold on, yeah, I gotta go get it. It'll take me only a second.
Okay, well, until he's back, we're gonna go back to CBK Wahoo, and so we're not gonna power this one right yet, but we're just showing off the pieces, right? So we got one, and right? And then the fans go on. And then we got number 2. So we got 2 Orgonite mushrooms with the magic plasma light bulb that goes on top that has some wild plasma, healing plasma with frequency generator. This is actually quite the advanced little setup that, shout out Chris, greatly appreciate.
Yeah, that's awesome stuff, dude. Nice work.
Right? Beautiful work. And then there's a second one to open up, but we'll let Joe go first, and then we'll get back to her. This is a groundbreaking show.
You know, these rocks get a little antsy sometimes, so let's see what they do right now.
Whoa. So it looks like there's one going to the crystal and the rest to the gold.
Yeah, let's get rid of this guy. That one's a little big.
Damn. Straight wizardry. Authorities don't come burn Joe at the stake. He is not a witch. He is just a scientist. Just a scientist.
I'm a conspiracy theorist. Hooray.
No, you're a conspiracy scientist, okay? There's a difference. This is conspiracy science at its finest. What happens when we zap the Cabellion through quartz with plasma? Is an angel or a demon going to come out of it? Nope. Nope. Look, it's just a book.
Nope,
It's not just a book.
And nothing's doing with my damn piece of rock either, which is crazy because I've zapped this rock like under less crazy circumstances and had it like move around and stuff.
It's being centered. It's being held by it. Well, thank you, Sean, and thank you, and shout out Sean Calderon, because if his contribution through the science that we've already presented, gone through today, wasn't enough, oh my God, look at what we have. Okay, it's time, Nathan. No, you got to come. Oh, boom. Sorry, Joe. Look at what. Bam, Sean Calderon. Shout out, our man sent us a microscope.
That is awesome.
Look at that, right?
Awesome.
Bam. Just arrived. We are going to be looking at samples all night, all day, all week long, pretty much now. We don't have a choice. We're going to be working overtime. And shout out to Sean for sending that and making that happen. We got all the tools that we need in the lab now. And that was Santa Sean came and saved the day, and now we're going to be able to compare our different types of crystals, and see, and you will be rewarded. That's where you give and you get rewarded because we will use it. All right.
I lied. There was an effect on this, but after the fact, it's always rotational. Okay, and if you rotate it, it starts moving around.
Oh, okay.
And it gets like little pull events downward. Yeah. Weird stuff, man.
That's what we're all about. Finding the weird.
Mm-hmm.
Because then we start feeling normie. Because we're like, hey, we're around weird things. And yes, exactly, Samo Goofonian. Thank you, Santa Sean.
That is awesome, dude.
It's next level. Next level. And okay, now for box number 2. Shout out also Santa Chris, Santa CBK Wahoo. We are opening up the second box live on stream, getting it done. And it's like Christmas here today. We got the microscope. We got the first batch of these Orgone plasma generator. And oh yes, the one, the only. We got the Onk. We have the Onk plasma, like,
Oh,
whew,
nice.
I
Yeah,
can't wait.
Juan was telling me about those a while ago. He was saying he could
Right?
like them.
Truly, Santa and Christmas came through today. This is Christmas in January. What a day! Oh my good golly, Miss Molly, we got two. We got double onks. We have the power. Shout out Chris for these, and look at the exquisite coils, crystals in it. We're going to be doing all sorts of healing
And see, I want to zap
experiments, not
those,
health.
man. That's what I
What?
want to be zapping.
Right? It's like, so we're going to try zapping this. Oh, another bulb, and oh, a diamond gem style. I love it. I love it. Thank you so much, Chris. So, it has been one full Santa day today, and we have so many more experiments and work to do, and that's what we're here to do, so it couldn't have worked out better. And on that note, I'm going to let Nathan take back the chair, and bless you all. I'll be joining in from the outside in a bit, and Sean and Chris, today's double heroes. Love you all, and we'll see you in a bit.
Right on. So, while Nathan's looking to take over, I was talking about the Kabbalion before, the Kabbalion. And as I said, at one time I read this entire thing multiple times, and something had just went straight over my head. And I just wanted to share it. It's a couple quick pages to read. And
Absolutely.
just mind you that it's from like 1908. So, it's very fascinating to see the connections that they were making here.
Real quick before you
Starts
read
off,
it,
hmm?
Joe, I just want to say thank you
Yeah,
uh, to CBK Wahoo and also to Sean. Dude, you guys are totally awesome. You guys hooked up things, man, and you're gonna make our whole time here more better. I don't know a better way to say that. I'm sorry, Joe. Go ahead.
Exponentially more work, and we love it for you.
Yeah, there you go.
no, that's awesome stuff, man. Can't wait to see what comes out of that. That's great. All right. So this says that gender is everything, is in everything. Everything has its masculine, feminine principles, and gender manifests on all planes. It's the seventh hermetic principle. Okay. I'll start off in the science part of it. Um, okay, there it is. It says that the principle of gender among the corpuscles, ions, and electrons, which constitute the basis of matter as science now knows the latter, and which, by forming certain combinations, form an atom, which until lately was regarded as final and indivisible. The latest words of science is that the atom is composed of a multitude of corpuscles, electrons, or ions, the various names being applied by different authorities, revolving around each other and vibrating at a high degree of intensity. But accompanying statement is made that the formation of the atom is really due to the clustering of negative corpuscles around a positive one. The positive corpuscles seeming to exert a certain influence upon the negative corpuscles, causing the latter to assume certain combinations and thus create or generate an atom. The word gender, by the way, is we associate it with sex. Gender evidently is a word derived from generate. So it says this is in line with the most ancient Hermetic teachings, which have always identified the masculine principle of gender with the positive and the feminine with the negative poles of electricity, as they so call it. Now, a word at this point regarding this identification. The public mind has formed an entirely erroneous impression regarding the qualities of so-called negative pole of the electromagnetic field or magnetized matter. The term positive and negative are very wrongly applied to this phenomena by science. The word positive means something real and strong, as compared with negative unreality, or weakness. Nothing is further from real facts of electrical phenomena. The so-called negative pole of a battery is really the pole in and by which the generation or production of new forms and energies is manifested. There is nothing negative about it. The best scientific authorities now use the word cathode in place of negative, and the word cathode coming from the Greek root meaning descent, the path of generation, etc. From the cathode pole emerge the swarm of electrons or corpuscles. From the same pole emerge those wonderful rays, which have revolutionized scientific conceptions during the past decade. The cathode pole is the mother of all of the strange phenomena which have rendered useless the old textbooks and which have caused many long accepted theories to be relegated to the scrap pile of scientific speculation. The cathode or negative pole is the mother principle of electrical phenomena and of the finest forms of matter as yet known to science. So you see, we justified in refusing to use the term negative in our consideration of the subject and insisting upon substituting the word feminine for the old term. The facts of the case bear us out in this without taking the Hermetic teachings into consideration. And so we shall use the word feminine in place of negative in speaking about that pole of activity. The latest scientific teachings are that of creative corpuscles or electrons are feminine. Science says that they are composed of negative electricity, and we say that they are composed of feminine energy. A feminine corpuscle becomes detached from, or rather leaves, a masculine corpuscle and starts a new career. It actively seeks a union with a masculine corpuscle, being urged thereto by natural impulses to create new forms of matter and energy. One writer goes as far as to use the term, it at once seeks of its own volition a union, etc. The detachment and uniting form a basis of greater part of the activities of the chemical world. When the feminine corpuscle unites with the masculine corpuscle, a certain process is begun. The feminine particle vibrates rapidly under the influence of the masculine energy and circles rapidly around the latter. The result is the birth of a new atom. The new atom is really composed of a union of the masculine and feminine electrons or corpuscles. But when the union is formed, the atom is a separate thing, having certain properties, but no longer manifesting the property of free electricity. The process of detachment or separation of the feminine electron is also called ionization. These electrons or corpuscles are the most active workers in nature's field, arising from their unions or combinations manifest the varied phenomena of light, heat, electricity, magnetism, attraction, repulsion, chemical affinity, and the reverse and similar phenomena. And all this arises from the operation of the principle of gender on the plane of energy. And it actually does go on, but I think that kind of shows the connection there that was sort of made regarding matter accumulation from energy. And I just thought it was super interesting that in 1908, science was kind of starting to say things like this, but there was a lot of back and forth as to the whys. This just took the old world philosophy of duality, gender, and so on, separated it from polarity, which is a little bit different, and then basically said, well, we know that it's male and female that is of creation, and that's at all levels, right? So if you're creating new matter, it's going to take both the masculine and feminine piece in order for for it to come together and Yeah. So that's all in there. And it's fantastic.
Dude, that's really cool.
Mhm.
I agree with that, by the way.
I do too. Yep.
Yeah. And I like the fact that he made a distinct point about the magnetism being misunderstood, about positive and negative in there. So I
Yeah.
like that too.
It goes to show how far back our very frustrations that we live with today exist.
Yeah.
He literally put in there as some institutes decided to name it, as if basically saying as if they're different in the first place. We know that I know that they're not, but they're saying they are, and we're not getting into a science argument right now. Like that's
Yeah.
like basically saying that they'll attach a name to anything. They'll put a description on anything. And when he said so-called electricity, it's like that's to an average reader, I feel like you'd glaze right over that part. So-called electricity, I mean, it's electricity. It's like, no, that's the manifestation of electricity or current via energy. And
Yeah.
it's like that's why it's so-called, is because realistically, it's a manifestation of energy.
That's why I
So
like the term energy much better than voltage or anything
I
else.
am.
Yeah. Because it truly describes what's going on, because it converts to heat, to everything else. You know what I mean? Everything converts in one way or the other. That's why it's never destroyed. So it's always present everywhere.
So I don't know that you might have missed it. I'm not going to go far into it. I couldn't record it because, first of all, it kept on cutting off my phone in the first place because it was putting in huge amounts of electromagnetic,
I
interference.
saw the wand and
Well,
the book.
yeah, but so okay, but what I did previously actually amplified it significantly. So,
Okay.
but I made this box, and I'll show you the box. It's not much to look at, but it's all hexagonal cells,
Mhm.
like cardboard hexagonal cells that are sealed off on both sides. I had all these blocks. They were like packing material. So I actually combined them together to make like a CME structure. And I placed the CME structure over like low hertz like resonance. Although super low hertz amplified so much that even at low volume, it was impossible because to dampen it without holding it, because you have to keep it dampened in order for you to actually have a good effect, right? Or yeah, you need to secure it from moving, right?
Mhm.
Well, long story short, I was able to get it so amplified that it was able to basically move the rocks. And it wasn't through the vibration, and that's where the misconception would be, right? You'd be like, well, of course it's vibrating, of course, like, yeah, but it wasn't just that, because when I took the wand that I just showed you, right, and
Yeah.
I moved the wand over it, well, then all of a sudden the whole thing amplified the electromagnetic effect. Okay,
Oh.
the rocks that were on top of it started moving with the wand, and it would immediately kill the sound because it created such electromagnetic interference that it shut my speaker off and
Oh.
and killed the Bluetooth connection between that and my phone.
Nice.
So yeah, so that's how that worked. Yeah,
You say it's hexagonal, a five side?
yeah. Or it's I think
Or is
it's
it
hexagonal.
six?
Yeah, it's six-sided. It's the
Okay.
same as like a honeycomb.
Oh, okay. Well, then that makes all the sense in the world.
Yeah, well, that's why I did it. Hold on, let me show you. It's it's nothing really much to look at, but you'll see. Literally just a couple boxes taped together, but in such a way. Right, so I have it configured like two different ways, right? So you could actually see some of the open cells here. I didn't seal them all off,
Okay.
right? But there's like multiple boxes here taped together, right? And then I left a void in the middle here. Oh no, this isn't the one with the void. This is. I don't know. One of them has a void. And there's just a piece of paper on top of it.
Nice.
So it acts as like a resonance cavity, right?
Yeah.
Well, if I take one of the
Ravenikov.
pieces, right, it is Krapenikov. It's exactly that. So now if I take this piece of paper off, right, this other piece, see how this is offset? that's at a 45-degree angle. So, this has different effects in terms of its resonance. Now,
Okay.
what I can do is I could actually take this piece of paper off, and this keys into that perfectly. And it keys in a couple different ways, right? So that's sort of what I was doing, and I was putting it on top of a speaker with a few rubber bands around it, so it was like kind of staying down. Yeah,
Interesting.
yeah, it was a fun little experiment. But I'll tell you, at very low volume, it'll start shaking your room. So, like, and maybe not crazy, but you could feel it in the air how much it's shaking the room. And if you were to close all the doors and stuff and let it build, I bet you'd have like friggin' pulse waves inside the room just
So
from having that effect.
you're at a super low frequency, right?
I mean, I use various frequencies. I actually used a recorded beehive sound, and that was really effective because you see what came to mind was, well, the bees is a hive, right?
Yeah.
And
The
Kravinikov
cavitation.
himself said that that's how he discovered the effect in the first place. Was there was underground bees, that had a big hive, and he just so happened to be sitting on top of this hive, and there were bees in the hive buzzing with their combs in the cavity in the void, and he said it made him feel like, he was out in outer space, and then he wasn't feeling well, and like all these different effects because it was just reverberating that exact, amplified frequency through him. So,
Yeah. Well, it's very interesting. He did a bunch of tests with people and then put the beehive stuff over their head to see what it would do. So, yeah, it falls right in line with what he was doing. Absolutely. All right. Sean sent me some more stuff. Let me see. I'm just going to bring it up this way.
yeah. Dennis had good advice. Sweep the tone generator to find the Rocksmith harmonic. Yeah, I was doing stuff like that, but there were certain pitches that were just so loud, even at low volume, that it was like you didn't want to be in the same room with it. So, yeah,
That's just cool. You know it's working then.
I'm telling you, it's no joke. Like, the resonance chamber, it gets the big waveform, and then it folds every single cell into resonance, and then they feed that big one, and it becomes just like this. Yeah, it's really, really intense. And it actually, at certain tones, sounds really good. Like, you don't know where it's coming from. Like, it is just emanating. So,
Really?
yeah. Oh, yeah. Very, very cool stuff.
Dude, that's rad.
Yeah, well, it puts your whole room into that resonance, dude.
I'm gonna have to get some directions on how to make those boxes, man. Let's get some.
Yeah, I don't know where I even got those boxes. They were like literally like next to the dumpster or garbage or something like that, and I grabbed them.
Why not? All right, check this
Anyway.
out. Man, that thing is small next to his hand.
It is, but it's stable, huh? Is that a video or a photo?
Dude, that's a video. It's
Wow,
perfectly
that
stable.
is unbelievably stable. Oh yeah, look at that.
Wow. Let's see. This is a general self nucleating wrap paper clip 30,000 kilovolt 30 cal. Yeah. Wow. That is super clean. He says find the soothing. Dude, that yellow on the outside just got me.
Yeah.
Look at his hand. It's glow. It makes his hand glow too.
Yeah, it's right. It's glowing yellow. It's almost like a sodium lamp color.
Yeah.
Well, I mean, if he's using any salt, it's possible he's actually, there's a bias to that bandwidth.
I don't think he has anything in there but the cathode.
No.
I don't
Yeah,
see
no, he said
anything.
it was a self-nucleating. So I mean, he nucleated the cathode.
Yeah, so he burnt down the cathode a little bit and used it as a reservoir to start it. Yeah.
Yeah,
The background sound, Lulu, what is that? This is a machine running, right? That's what it sounds like.
yeah, that's what I thought.
Okay. Is it mute
He says the next video is
modulating? Yeah,
strange,
whatever.
Nathan.
Okay, well, hold on. I just want to hear it again.
Yeah, it sounds like somebody's talking over the woo in the background, whether it's a radio or somebody talking. Sounds like a radio, though. Sean, did you have a radio going at the time that you filmed this?
You know, I've had this happen before. When you take high voltage and you put it in and you take a coil, big coil, and it sparks over to it, it makes like an alien sound. It gets really pronounced. Okay. Or if you have the voltage hitting something. Now, this isn't hitting anything but the bottom piece, but I'd imagine that's the sound of the RAV itself. Oh, it's
Okay.
a TV.
Yeah, that makes sense because I was gonna say if there wasn't something on in the background, you're picking up some transmission with this because like that was definitely the sound of a transmission, you know?
Oh, yeah. Lucas is picking something up. Absolutely. Picking up TV, apparently, in the 1950s. Oh, wow.
Yeah, right. Listen, if the Yankees come on from back in like the 40s or something, you know that you did something right.
The old Captain America thing. Got it. Nice.
Yeah. Well, like Mel's Hole.
Ha! Mills Hole. I love
Yeah,
it.
he said that happened. He said that he put it on and it was a baseball game from like 25 years prior.
Oh, there you go. Twilight Zone. All right. So let's remove that one. Let's go ahead and do another one. Sean's got another one here. I wanted
By
to
the
see
way,
what
did
this
you
one was.
use the Geiger counter yet?
No, I haven't.
Uh,
I haven't started up any experiment in the garage yet.
okay.
Yeah, we've been honestly just kind of getting settled in. You know what I mean? Bernie
Mhm.
came trying to figure out where he wanted to stay at. You know what I mean? Where he's comfortable, kind of getting. We're on two different schedules. I'm up at 2 in the morning. You know what I mean? He's up much later, so and he's up later at night, and I go to bed early. So we're just trying to figure that out and then get the work done.
Awesome.
So yeah, dude, it's awesome. It's just gonna take a little bit because you know what I mean.
Mhm.
Certain days I watch my granddaughter, stuff like that, so I'm kind of out for the day. So we got to get a real hard schedule going for everything.
Yep.
So,
Well, comes with the territory.
well, the cool thing is we went out shopping today. We picked up a bunch of ball jars. You know what I mean? Got them
Mhm.
set up. He has his own area behind me or in front of me, I should say, and he's setting it all up. We got a bunch of wire out. Um, so he'll be making a bunch of coils in there. He's got some power strips over there with the 5 volts. So
Mhm.
starting some reactions. We were screwing with potatoes yesterday. So we got like almost 10 volts out of the potatoes and 2 amps. But because there was no pressure on it, I couldn't start my Tesla coil. So there's just no pressure in the line.
Mhm.
And I think it comes to the way because they're acting like batteries, but
Yeah.
weak batteries. So it needs like a magnetic field to draw a hard line in it, so that it has push to it, right?
Yeah.
Or something like a capacitor that would do the same thing, have magnetic field in it, so you can have push. We were missing that in our experiment, and we were looking at it thinking, you know what, we should put together a simple see-through capacitor with different plates in it, kept it the same spacing by a little bit of PLA, little
Mhm.
plastic in there,
Yeah. Yeah.
and then show how it bubbles and everything in there with whatever liquid we decide. But then you get the very good magnetic field going in between each one of them. You know what I mean?
Mhm.
I think that might get it done, and then we can start a Tesla coil with just potatoes.
That's funny.
Yeah, I mean we had the voltage and amperage. It's just we couldn't get the push.
Yep.
Uh,
Nope.
uh,
Yeah. Right. You got nothing to vector it. It's all potential.
yeah,
Right. You actually need a load on it, or like you said, you need a magnetic field. But you need something to either pull or you need something to push.
right. Now you're getting it right. So
Hmm.
it, it's it was an interesting thing because if it was just a matter of scaling, dude, I had no problem go buying a couple bags of potatoes. You know what I mean? Keep hooking them up, but it wasn't. It was there was no push to it. So it was like as much as we could gain out of the voltage and amperage, it wasn't going to push it hard. It'd light up an LED. You know what I mean? Something that simple, but
Well, not for anything. This is actually a very similar problem that you face when getting energy out of systems.
yeah,
Is that if you're taking it out of the well, but the well isn't in motion and there's no pressure going to it, then how do you get it out? You got to draw it, right? You got to draw it out, or you got to pull it out. Like like you said, inducing magnetism is not a bad way
yeah.
to increase the compression, increase the pressure.
Exactly what I was saying. So a capacitor would do it if it's at the right value, or magnetic field. So we put a choke on there and had a small magnetic field around it. So it started to get a little bit better on the light. So there's more to it, I guess. We have to figure it out, but it was still worth a try because we got energy out of it. So it was promising.
8.5
Very cool.
volts.
Yep. So all right, I won't bring this back up. Where did it go? Yeah, and he put that thing through the ringer, didn't he?
It looks like it. You said this one was weird.
The plasma is growing in the left corner, the white tube. Okay. There's clay powder on it. Okay, that's why it looks that way.
The left corner. I'm assuming the left bottom corner.
Yeah.
Hmm.
I'm not seeing it.
I'm not seeing what I need to see here, or what. I actually see like what appears to be like some kind of rarefied gas reaction, some type of something going on at the beginning. I still see that. I can see the flow from it. Do you see the flow coming out past it? You see that?
Oh, hold
Look,
on.
look at the bottom, but I don't see the. Oh, okay, wait. I can't
Oh,
tell where the rab is though, but I see this flow going past the bottom part in the pan, which is interesting.
yeah. Well, I see one broke off, like about 3/4 of an inch higher than the bottom piece on the left hand side.
Yeah, I see that.
Okay, so it was building something out and it snapped.
You see what I'm talking about, that movement though, don't you?
In the water, yes.
Oh, it's in water. Okay. Well, now it makes sense.
So there's a piece right there, and then right there it just snapped.
Okay. Yeah, I see that. Mm-hmm.
But I'm not seeing growth on the bottom piece under it.
No, I
He
don't
says
know.
that part
I
grows.
think I need to look closer to see, on my own time. to kind of really break it down.
Yeah, he's talking about a brown leaf. It's got to be the one that looked like it broke.
Yeah.
Because the one on the very bottom looks consistent from beginning to end. Underneath it, I don't see any difference in that. Yeah, see, there it goes. But that's interesting if he's got clay powder in there, then. You know what I mean? It means that it's taking on the clay under, and the structure's under it. That's different. You know what I mean?
Yeah. No, I get that. Like I said, I'm gonna have to look at this one. I don't know. I'm definitely missing something, but I don't know what it is yet.
I don't think we're missing it. I think it's strange because it came out brown because you put the powder on it.
I mean, if you have the clay, I mean, yeah,
That's
I mean, I think
interesting.
that's right, like iron oxide. Like, I mean, I agree with that. That looks like rough, like rust all day. And usually the clay is high in iron oxide. We know that.
Yeah, Sean, don't worry about the video, man. We're just trying to figure out what you saw.
Yeah, exactly.
Yeah, that's what we're looking for because Sean shows us stuff because it has something interesting in it. So
Yeah, I don't know. I'm missing that part.
there we go. It's just transmutations. That might be something there. Yeah.
Interesting. I dig it. Sean always comes through with the new and the good.
There you go. So
Yeah, the
yeah.
Brahma footage on. I mean, yeah, I mean, I saw that. That was there from the get go. I didn't.
So we'll look. Oh,
What's
hold
that
on.
click on top of that? Like, what's that click?
Okay.
Like,
So hold on. You see the structure that's the 1 inch up, and we saw it bend, right? Exactly to the opposite side of it, there's a reaction.
yes, I saw.
Right.
I saw the bottom right. When it clicks, it. Yep. See, boom.
It
Like
broke
sent a
something.
bubble down or something. Something went.
Yeah, it's that. It's that piece.
Okay. Run it back. Okay.
It breaks as soon as you hear it, you see it move.
Yeah, and then it flashes in the bottom right corner. You see it moves in that direction, flashes bottom right corner. Okay.
Oh, that's actually cooler. So he had some kind of structure going straight through the whole thing.
Yeah, I was wondering where the hell it was because you don't see it here. Yeah, so it was building through the tube.
Yeah, so from left to right, yeah.
Well, do you remember last week when I said to you, I said, it'd be interesting is if you take Bernie's solution, okay, right, and you run a charge in Bernie's solution, and then all you do is you take a clean jar of water, you run a wire from Bernie's jar to the other jar, right, and then you just run your RAV reaction over that water cathode, like you normally kind of would, right? And what I was suggesting, right, is that you would have material deposition in the clean jar.
Yes.
That's what I was supposing. But I mean, that doesn't sound like that much. It sounds like electrolysis, but when you realize is that it's leaving the water and entering into the other jar, right? So that's sort of the main thing there is, showing that you could actually move material potential electromagnetically in that fashion.
It almost sounds like a transporter.
Correct. That's exactly what it is.
Yeah, you dissolve something into energy and then rebuild it from energy.
Right. It would be using the material potential that it's breaking down and allowing it to travel as a carrier wave. Because again, those okay, so it structures okay, like when it wasn't holding together, and we said it right. We
Mhm.
said it structures based on the energy in the system. Okay, that's why when you turn the energy off in the system, it was falling apart. Right
Mhm.
now it's staying together because the configurations have changed, but we're not talking about that. We're talking about when it was falling apart. Right. Well, before it had any binding in that case, right? All it was loose material. Okay, and it was being held together by the only potential that it was contingent on the system, right? Now, if it wants to make union, like what I just read and what we've been talking about all along, right? It
Mhm.
wants to make union with the energy that's causing the rab, but the rab is on the other side. But it's got an electrical feed from
Uh-huh.
point A to point B. So it's going to ride with that electrical feed, into that other potential state in order to make that union because it already has an attractive force with the current from the system. We know that because it structures it.
Yes.
And we know that the combination is what it wants and it's not where it is. So it's got to move.
Hmm.
So it becomes transient. So you should be able to get material from one jar to another with nothing more than a wire. Should. Now, the catch-all here is that you got to have the good pull from the anode. Same problem as you're talking about on the other
Yes.
side. You need to have
Yes.
the pressure of the anode be able to reach the wire because unless if some anodic energy goes down that wire, okay, that's like a circuit knowing if there's something to light on the other side, right? Like, well, it just won't put current down there if there's no load, right? Same
Mhm.
same exact situation. They have to know that they're in proximity. Once the relationship is made, then begins the exchange.
Hmm.
And there you go. And there you have it. You
Trying to
know?
think of a
So
way to get that load there. It's got to be something I'm not thinking of right away to do
what's
that.
that?
Well, to get the load there so that we can pull the matter in.
Well, I think that just that's the point of the anode in this case, actually, right? So if you have the anode and the
Mhm.
anode's
Oh,
actually able to put positive masculine energy right down the
no, no. I have the
um
answer. I
yep,
have the
okay.
answer. So if you took a syringe, okay, and you open it up and sealed it around the wire, you can pull it and it'll pull the vacuum inside of it. And as it pulls the vacuum inside of it, voltage actually will grow inside of it and follow the plunger. So they do it with Tesla coils all the time. They go over, they put the thing there, and they open it up, and it pulls the plasma inside the tube itself. But that would be enough for to get the pull to get the energy to that spot. Then we could see if it grows inside that syringe.
Well, you could, but I think that the real experiment is what I said for the simple reason that there if as long as some of the positive energy from the anode is making it to the wire, that should be enough stimulation for the relationship to occur. Okay, which then should allow for because what you're saying is fine and well. Okay, but the thing is that the material is already there. So you want to see what I want to see is if you can virtually with electromagnetism move the material, right? And that's the point. See, so with the
Well,
syringe, it's kind of bridging the gap. Don't give it any help. See if it does it. Bernie says it will. I mean, I
yeah,
don't. Bernie says it will. I mean, I propose that it might, it may.
you need a
Um,
capacitive charge state. So you needed to create a capacitor on there to create the pull. But it's just like an open air capacitor. It doesn't have to be anything else. Just like remember we saw Sean had that electrode and that little plate. and then he hit it once, did nothing, hit it second time, did nothing, hit it third time, created a vacuum. Exactly what we need. It's not a syringe, but it's still a vacuum when the charge is right. That means it'll pull the charge to one side.
Yeah. So I don't know. I'm just making a proposal there. You know, I know that if you were just to put the, let's say there was no monoatomic in it, right, and that wasn't the point of what we were doing, right?
Mm-hmm.
If you were just to take one jar of water and charge it negatively, right, and then run a wire from one jar of water to another jar of water, right, which all it has is the second wire, that's going to be enough for that second jar to be then cathodic.
Okay, well,
Right.
we'll try it that way.
That's sort of, I mean, that's sort of the idea, at least, right? I don't know. Once you put the monoatomic into it, the question then becomes, do you get accumulation? I don't know.
Okay.
Ask Bernie, see what he thinks. He seemed to think so.
Well, the pressure between the two might do it, given the third and open valve to push out.
Yeah. Bernie, does that work?
Bernie, does it work? He's over there filtering something right now.
All right.
Yeah, I'll leave him alone.
You're doing good.
All right, well, I'll take a look at that video Sean sent real quick. He sent me another one.
It works. We got purple gold.
Nice.
Ooh.
Bernie, what I was talking about last week with the jars and the cathode,
The
with the
jars and the cathode
monoatomic,
last week, Bernie?
Yeah.
That's what he's talking about. Will it populate in the third one if you have the two
in the
jars?
second jar, yeah.
Oh, yeah, we're gonna talk about that offline more, because of the implications of that before we discuss that further live. Yeah, I got a cameo going. Woo wee.
Well, there you go.
Yeah, we'll have to find out how it works. That's for sure.
It doesn't work, so we have to talk about the implications offline. First.
Yeah.
First.
I also got the monoatomic silver zinc here too.
Nice. Be looking at that stuff under the microscope here soon.
Exactly.
Shout out Sean, man.
Shout out Sean. Good thing I smuggled these over the border.
Everybody says smuggle them over the border.
Yo, U.S. Customs is a thing, Bernie. I'm just saying. Anyway.
Oh, it's so great. Okay, Sean, here we go. You want me to try that?
That one has the rub on it. That one has regular seasoning.
That's chicken, right?
Yeah, they're both chicken.
Is it still pink?
No, it is not. I ate them.
Okay. Sorry, my daughter's bringing me something right now. Here.
And shout out to her birthday.
So at the end, the rate changes. You'll see that. There it goes. Yeah, so what he's doing here is it's interesting. It goes along with what we're talking about, but it's not exactly the same because it looks like he's putting a drop, and I'm assuming it's salt water. Maybe I'm wrong. I just don't know enough to really say, but it's like I think he's putting a drop of salt water on the bottom there. And then it's basically, I think it's pulling the salt or mineral composition out of the water and structuring it.
So hold on. Watch the water level. Look at how low the water level is to where the voltage hits as it
Mhm.
plays. It's sucking the water into it. It
Yeah,
just took a
raised
big
up.
gulp. Yeah. So we'll do it
Hmm.
again. As soon as you moved it, it boom, automatically jumped up. So it's creating a vacuum.
Yeah, I was gonna say things don't do that. You don't drop water next to a tube and have it suck it up.
Yeah.
What's funny is that I would say that you know, by looking at it, you would think that there's probably a positive pressure in there, right? Because of what the anode is doing, but it's not. And I know why is because it changes the potential, right? So since the potential in the cathodes side of things, right, is dependent on mass to a degree, right?
Mm-hmm.
That's where its potential is going to come from before it's split. By
Well,
adding more in, the energy, is going to pull at it because it's expanding its potential because it's able to then actually change the offset differential with the anode.
yeah.
Even
Mike
so,
here
it's a,
says the plasma sucks the water gets transmutated due to the high voltage, creating hydrogen and actually making the light brighter.
I don't disagree with that.
Makes sense.
I'm on board.
Now you can see it gets brighter when he pulls it in, that's for sure. Yeah.
And that's exactly what the potential is. That's why when you run, negative energy with matter, it's gonna, and then you introduce the anode. Once that exchange begins, it's gonna start the breakdown. That's where the electrolysis portion of it comes in.
Mm-hmm.
Um, with no RAV, though, there's no non-equilibrium separated state.
Yeah.
So this is actually a direct feed of standard ionization.
See, that's so interesting that it does that. I love the color
Very,
difference too. Yeah.
yeah, it's very cool. Is
Because
it
it looks
regular
like
water, Sean, or salt water?
it says it's tap water.
Tap water. Okay.
Well, you see it dissolving it, and then you see it suck back up and just take more drinks.
I mean, is it evaporating or breaking it apart or whatever, for ionizing it? And is it, or is it in states of different compression and decompression? Like, I don't know that either, to be honest.
Mike says, I think it's a similar way to was happening with Stanley Myers' water car.
Yeah, and that's actually what I was just saying about the compression and
Yeah.
decompression. I don't know that its volume, right now is being dependent on the pressure differentials. So right now the anode's winning, so it's compressing the cathodic liquid. Once he adds more, the potential changes that relationship, decompresses, creates a vacuum, sucks it in, decompresses, fights
Yeah.
back the anode a little bit.
Well, he's kind of giving us an answer, isn't he, on how pressure works in his.
Mm-hmm.
It's pretty interesting.
Doesn't use salt water for any of his experiments. Okay. Yeah, I mean, you had mentioned salt earlier. That's why I wasn't certain, but that clarifies that.
Yeah, he thinks it actually alerts the frequency of the RAV. Yeah, Sean's in agreement with both of you.
Mm-hmm.
Nice, very good. He is so awesome.
Sean's the best.
Yeah, he
Yeah.
says he used the salt rocks That was it. Sorry for the confusion.
Oh, okay, gotcha. Yeah, I mean, and with this, the reason I said about the evaporation is, I mean, you could make a claim for ionization and just plasma, but
Uh-huh.
as you see, there's no lingering or accumulation of plasma that's going on there. There's no combustion event, and there's no apparent um, steam or evaporation discharge that you could see. So that's why I proposed that it was compression.
Well, Sean says the frequency drops, and you can see it in the plasma.
Oh well, I said the frequency drops. You could hear it. Well, I could hear it. I don't know that you can, but I said
Can't hear it,
at
dude.
the end.
I could see it. Look at it. Look, you
Yeah.
got a faint yellow and purple or just a blue on the bottom, right?
Yep.
Then it's going to turn into a bright yellow, which means that it changed the frequency and lowered it. Because that color yellow, when it gets real bright, is a lower frequency than the purple.
True story. You could hear it though. I'm just saying.
Well, yeah. I'm glad I could see it so I can understand it.
Mm-hmm.
My ears don't work for nothing. There you go.
Right there.
Computer Earl Grey hot. Nice. Star Trek. Oh yeah, he's got different frequencies going this whole thing the whole time. I'll tell you that right now. You can tell the frequency by the color of everything. The quartz
Yeah, very
tube,
cool.
nice.
I'd like to see the RAV form, but it doesn't look like it has anything to nucleate. You know what I mean?
Yeah.
I think that that's probably the thing with it.
Yeah,
Because
the water.
that's what we know is that we need it needs the intermediate.
Yes, something.
So
No, water's
it's
not it.
an intermediate.
Nice, dude. That's so cool. I like it. We'll be trying that one out. All right, Bernie, what do we got going on over here?
All right. So we have purple monoatomic 24 karat gold that started out as the white monoatomic, but this sample here is silver. And so we got silver right there, pure monoatomic silver. And then we have pure monoatomic zinc. And then we have more of the purple monoatomic gold or monomolecule gold that I believe is photonically bonded. And then this one is purple silver that is photonically bonded. And the silver I got by putting into a full moon, and the gold from the summer solstice sun that it did the
Wow.
purple photonic bonding from. So we got some samples that we are going to be looking at under the microscope thanks to Sean. So yeah, just filling it, rinsing all the salt out of the process so that when we dry the powders out to look at them, that it will not be salt crystals within it. It'll just be the pure monoatomic. So that's what I'm doing right now, just flushing it.
It's all new to me, guys. Be a whole lesson in this for me. This is cool. We got to set up the camera over there.
Bernie, do you have any monoatomic copper?
Joe was asking for monatomic copper.
We were going to be making that one next.
He says we're going to be making that one next.
All right, Bernie, I have a challenge for you. I want to see if you.
Sorry.
Hold on, I just answer this. No, never compromised by the government. That's for sure.
Wait, I already got some here. I forgot about this sample. So there's the copper, monatomic copper.
All right, you have everything you need. Check this out. Hubert Smithite, man. Okay. Zinc, copper. Okay. Then
Couldn't hear you. I'm sorry.
Yeah, Hubert Smithite.
Hubert Smithite. Zinc, copper.
Zinc, copper, oxygen, hydrogen,
Oxygen,
Chloride.
hydrogen, chloride.
Okay.
So basically, salt water and zinc and copper monoatomics. Okay, if you could get it to crystallize standing wave in a cogome lattice, you'll have Hubert
Ooh.
Smithite. Okay.
Did you hear
Now,
that?
if you do
A
that,
bit of it, but
that's
half.
the magic rock. Okay.
Okay,
So
so we got the magic rock within all the elements that I have here.
what I'm
Well,
saying, zinc, copper, and salt water.
yep.
ZnCu3 parentheses OH close 6 and then Cl2. I will message it to you. That's the chemical
Okay.
making of it. And
Perfect.
all right. So if you could do that, you're gonna have the weird rock, dude.
Interesting. Okay, so we'll find the solidification process of it. I believe probably when we're experimenting with the frequency generator into the reaction, that's probably when we'll be able to actually crystallize it and make it into that.
Yeah. If you could do that,
We're
it's a
gonna do it live together, Joe. We're gonna
dude,
do it live together.
it's a multi-ferroic quantum spin liquid.
Ooh,
So
okay.
all
So we
right.
got some real wizard shit right there, is what you're saying.
That's what we gotta do, man.
All right, deal.
Oh, heck yeah.
Big things.
Different kind of lasers. Compressed ionosphere, same as plasma ball. Cause same. They say that they can make a little plasma ball out of 2 lasers. So, I'm not positive about that though, and I don't know the answer to your question.
Yeah, probably. I mean, that's hard to say because it would be local to. So anytime that you're going to shoot a laser emission, right? All you're doing is you're putting photons, right, or energy potential, okay, coherent energy potential. You're putting it into a directed transient state. It's not going to be manifest at a high energy level, okay, until it reaches its point of interaction. Because it has a scalar component, okay, it would need a pretty similar and high energy potential to reach a collapse state. So in order to get your point of light to actually hit something that's energy, and then have it collapse into that energy state where it's to the point where it's actually uh, dissipating that energy at that point,
Mhm.
it would you would need a lot of energy behind it in order to have anything. And if you had anything that wasn't in a super diffuse state, your time effect would be local to the event, just like
Okay.
any time event, right? Because it would interfere with, in my opinion, this is theory, right? The localized energy exchange of the area, because now you've introduced a secondary energy source, right?
Mhm.
So that's it would be hyper local, if anything, and chances are nothing. That's just my opinion.
Gotcha. All right.
Yep.
I want to say real quick. I got something here. We sell these Tesla coils on my site, guys. This is a quick promo for me with all the drivers that you would need for them. Capacitor banks, ZVSs. If you just want a Slayer Exciter circuit, dude, they work perfect. Every single one of them burning look beautiful, don't they?
Oh my God, yes, right? And it's always easier to come up and help sell someone else's product than show your own. So that's why I'm holding in the background. I was like, Nathan, you need to advertise because these things are amazing. And well, we're going to be lighting them up in the coming days and weeks. So, we'll put your order in now while they're still around because we're about to start showing what they do.
I also
Yeah.
want to get just real quick. I want to get to tell. Excuse me. I just want to tell Sean. I'm gonna put that in a box. That one right there, along with the capacitor bank, along with the ZVS, along with the Slayer Exciter, the NPN, NPNP. buddy, Bernie and a guy are gonna pack you a full box of toys to play with. So shout out Sean, man. We're shipping that out probably tomorrow. So or the next day. So just so you know, hope you're hope you're available at your house in the next couple days or probably the next week. But you're not, you're not placing an order, Sean. I got you covered on this one, buddy. Thank you.
Right on. Hey, Nathan, did you happen to get the Tesla limited edition portrait up on the site or?
It's on there.
Oh yeah, very good. So just a reminder, we have the Tesla limited edition portraits up on Shopify. We'll make sure that the links for everything, the Tesla coils, the artwork, and everything is up. In the description, and the artwork is limited to 24 pieces, and 20 are available. And I'll go grab it and show it to you real quick so we can move on.
Absolutely. Yeah, I want to see what Sean does with my work now. He sent me a bunch of stuff, and I got to play with it. So now it's nice for a good turnaround. You know what I mean? And see what he does with it. All right, guys, take a look. Just got these
There you
portraits, man.
Oh wow!
Got the
Look at
Tesla
that.
portrait.
Look at that.
Okay, got the metallic Nikola Tesla signature, that I did up on the bottom. I hand make each and every one of these, including all the matting. It has brushed copper matting behind the black, and it's done in my proprietary accurative deposition process. Each one is one of a kind and it's handmade. So if
Yeah,
you're
guys,
interested, they're on sale.
There's serious depth in that photo. Like the
Yeah.
way he layered it, there's like awesome depth in it.
Yep. Each portrait's made up of I kind of forget the exact count, but I think it's upwards of 30 layers that go into printing each one of these and making it. It's not just a straight print. It's nothing like you could buy in a store or even have made for you. It's something that I specially developed.
Yeah, hold it right there, Joe.
Mhm.
Yeah, you could totally see the depth of the Tesla figure. Is definitely has way more depth than the coil behind him right there.
Oh yeah, it's something to see. It'll look beautiful anywhere that you decide to hang it. It's a good size. It's about 20 inches tall and about 16 inches wide altogether. So it won't take up your entire wall, but it'll cover enough space to make for a nice conversation piece and for you to enjoy. So
Yeah, it's awesome, Joe. Very nice, man.
thank you.
So much cool stuff going on, man. There you go. Sean likes it, man.
Right. I mean, just for what it's worth, just for myself, I'm probably gonna make some of my other heroes. You know what I mean? Like have like a wall of fame going on because there's no reason not to. But that's all original artwork. It takes a long time to be able to put all that together, and then through my process, you don't only get to do it once. You get to do it once and say, this is how I want it to look. Then you get to sit there and break the thing down meticulously, layer by layer by layer,
Yeah.
as to exactly how it's going to go down on the paper. So it builds, and it builds like, from the first layer up. So, like I said, it's a very specific process that I undergo.
Well,
Doing it.
you should do Faraday, Maxwell,
Oh, yeah.
and Feynman, I believe is his
Yep.
name. Yeah. That would be cool. There's a lot of people out there that those are their, main guys, especially in this crowd here. You know what I mean? With all the stuff that we do.
Absolutely. Absolutely. For me, though, it was always Tesla, for what it's worth. I always felt like he had all the answers and just never got out with it. So
Yeah. Yeah, never gave them all away for free.
Yeah,
That
well,
I
right.
did know.
Dude spent his whole entire life just trying to fund his damn work, and it's like he put every dollar that, he could have used to be comfortable into his work, and every single time had his funding pulled. So
Yeah, especially
then he just
especially
tried to sell his ideas cheap, and nobody wanted to buy it. So
Can you imagine that, Joe? The smartest man when it comes to electricity, and all you had to do was, I don't know, give him a few bucks, and he would have done everything. I mean, that's insane. That
problem was like, and this is my speculation about Tesla. He's the kind of guy, I believe, okay, who you'd sit around talking science and business with him, and he'd tell you all about the idea that he wants to sell you. And he'd tell you everything you needed to know ad nauseum, to the point where any capable person that could, has the ability to act on it themselves could, within reason.
Mhm.
And I'm not saying that he said quiet parts out loud and so on and so forth, necessarily. But he always gave enough information for somebody to steal his idea without ever having to give him a penny. And I'm pretty, and like, he was probably the kind of guy that if he didn't want to tell you something, you could disagree with him on purpose and tell him that he was wrong, and he'll sit there and go against his own good judgment just to sit there and explain to you why no, that's not the case. And even if he's like consciously like, I'm not gonna say, I'm not giving this away, you could probably sit there and egg it out of him.
Maybe.
And he didn't have social skills like that, and his business judgment was historically awful. Why? That's why.
Yeah. Well, I'll say this. Shout out Steinman's as well. You'll never know what Tesla had to get rid of out of his system to make it work, or Steinman's got rid of out of the system to make it work without Steinman's. Because when you compare the two, you got your answer. All the special stuff gets cut out when Steinman shows up, and then the ordinary we're used to today is now what you see. But it's like the difference between running that Slayer Exciter and the ZVS, Joe. The ZVS, you get none of those effects that you feel in the room. With the Slayer Exciter, you get every single one of them, and it's
Yep.
special.
Oh
So
yeah, and it permeates.
yeah,
It goes through everything.
yes, it does.
Eventually. Eventually.
I got another energy source, man, that goes through everything.
Oh yeah?
You'll see after a while.
Yeah, was it beans or something?
No, it's not beans, man.
Oh, I wasn't sure.
No, when you start working with it, you'll understand a little more.
I got you.
But yeah, it's pretty cool, man. Man, we got a lot of good things going, man. So I went ahead and got on the CAD today, and Mike's pulse motor, the Renegade. We I built the center core for it today. Once we get that done, I could check it. We can put it on a board, and then we're gonna look at where everything goes, the coil and everything, and then I'll build those parts in CAD and print them out. So it's gonna be about a 10-hour print just for the centerpiece, uh, for the for the spinning part. Um, I went off pretty much on Mike's design and changed a few things on the bearings because I like double bearings and things instead of single bearings. I don't like things to wobble.
Mm-hmm.
So that was one of the things I changed. Also on the very top, instead of engraving the letters in there, I made a separate plate that glues to it so that it'll sit flush and flat and have a perfect look to it with the letters popping out like by 1 millimeter. So we'll be able to take the paint pen and do the same thing I did with the SG behind me, and that's going to look gorgeous, man. But all the rest of the stuff should be right there with us to do that. We'll have that out in the next week. So we're going to have Bedini's device ready to test. We'll have Mike's Renegade ready to test right afterward.
It's
Shout out,
awesome.
Dude, shout out Yanni right now. $20, man. You are so cool, brother. Thank you very much.
Awesome, man. Very
Dude,
generous.
let me tell you, this next 2 months is like the awesome time for us here, man. It's time to get all of them done. You know, with Bernie and me working on them together. You know what I mean? We could just focus on getting it done, man, and getting everybody the information. So
Get her done is what we're doing.
Get her done.
yeah, shout out Yanni, man. Right on, brother. Yeah, dude. I can't tell you how happy I am to get this done, Joe. Because we have some stuff that we're gonna film for the rap stuff too. While Bernie's here, he's gonna help me out and get it set so we can get the background right, and I can get the main part, you know, introed.
Yep.
And then Joe's got the evaluation going on it, man. So
Thank
It's
you, Yanni.
all
Right,
the
and
pieces are there.
anyone and everyone, if you can't afford to donate to Old Man Builds, I eat a lot, and we need funding before his wife Kristen, amazing lady, but she's probably gonna kill me by the time she sees how much I eat and kill Nathan. So, yeah. On that note, we're getting the work done. We're working hard, but yeah, it's we have to fund ourselves, so all help, all support, it's appreciated. Thank you, Yanni.
I heard that those monoatomics, they might not taste good, but they're pretty filling. Sit in your stomach like lead.
oh dude, yeah. We're good, man. No, my wife's not worried about it, brother. She feeds me, so we're okay. You know what I mean? My son eats twice as much as Bernie does right now, so we're all good. So, yeah, it's funny. Middle of the night, man, drop off food. I don't know when he's gonna wake up. It's great.
Steven
Yeah, but
says Bernie's got to try some boiled peanuts. They're awesome. I agree. Boiled peanuts are pretty good.
I guess
Spicy.
I can't eat
Yeah.
peanuts anymore.
No,
No, no
not
nuts
even
for
boiled
me.
ones, Nathan.
No, dude, I have no teeth.
It's a boiled peanut, and not to mention the food for people with no teeth forever was peanut butter. You know, like that was like it was made for people who couldn't chew.
Okay, well, peanut butter I can have. Yes.
Yeah, yeah,
Uh,
boiled. Yeah, you could do boiled ones then. Definitely. There's
I'm
some.
gonna bring up another video. Sean, send another one, dude. You got some awesome stuff going on.
Nah, man, that thing is just hanging out like it's like burrowed in the surface.
Yeah.
Like found itself or made itself a little pocket, and it's just
Just hanging
hanging
out
out
there,
right
yeah.
there.
Dude, I love how that plasma just bends every which way.
Mm-hmm.
We got to slow this down and look at it some more for growth on everything.
Yeah, yeah, because I see the bottom's active on that. It's funny that the little dendrites or whatever is going on down there, like they like kind of dance with the flow of the energy.
Oh, yeah.
Sometimes you notice they kind of wave back and forth. It's not wind or anything. It's just the energy. It's what's kind of building them and holding them together in that moment, so they move with it. It's part of their structure.
It reminds me of like seaweed or something. You know what I mean? Some kind of plant that grows and goes with the flow of the ocean.
Yeah. I mean, honestly, when you and Bernie are together, you guys have to do rap stuff because it's such a critical component that bridges the gap, man, between what we've been trying to do and what Bernie does. It's literally the bridge that brings the two sides together and shows the result for a change. So
Well, we're going to be setting up spark caps inside of water and see if we can catch a rav. You know what I mean? We'll precondition it outside and then hopefully we'll get the wrap structure to build. You know what I mean? I think that's
Mm.
going to be the way to go because we got all the right stuff that Sean wanted us to get as far as the anode and cathode, the small ones, the big ones, all that we have. So yeah, dude, we
Well,
got
I mean, if you want to capture the rev, it's kind of like I think it's kind of like we talked about, man. Like I think that you need to build it where there's like some kind of containment, but still something to nucleate. So it has to be like inside of something that it's able to nucleate. You
I get
know,
it.
so I think that that's probably the way.
Well, we'll find out, won't we?
I mean, it becomes a little Tomamaki then, but not exactly because not a donut, you know. But I don't know.
Well,
I
we'll
think if you
try.
just bored a hole into something into clay, man, where
Well,
it's narrower at the top.
I'm gonna try to just preset the cathode and make sure it works, and then we'll put it in water. That'll be the first experiment, and then learn from there. What looks right, what doesn't look right. You know what I mean? We saw Sean's experiment in the tube, what was looking right, what didn't look right, and we'll go from there. You may be right. We may be putting it in the cylinder after all, but I saw Bernie's run without one. So, you know what I mean? It'll be dependent on frequency and how much energy is actually going in there.
Yeah.
So, all right, man. Oh, let's take this down. Guys, what an awesome show today. Dude, it went by fast, Joe.
It did.
It's
It was a
already that
collab.
time. Oh my god! Wow, we are almost 3 hours in. That did
Yeah,
not
well,
seem like
yeah,
three
that's a
hours.
typical
No
Friday.
shit.
We do
Wow.
almost 3
Pardon my
hours
French,
usually.
but
Yeah,
holy shit, that went fast.
We create the dilation of the time field.
that's right.
Time flies.
All right, man. I just want to give out some shout outs here. Darren gave $20, man. Awesome, brother. Thank you as always, Darren. Darren also gave out 5 Old Men's Build memberships, guys. I want to thank you for that, man, and say hello to all the new members out there. Hope you enjoy it. There should be some good content coming up here in the next week. Bernie will be working on it with me. I want to shout out Yanni, gave out $20, man, as well. Dude, you guys are awesome. Thank you, Yanni, man. So, yeah, we got the Tesla coils for sale out there, man. Everybody who buys one, man, the numbers just go straight to our working fund out here. So, you know what I mean? As we sell them, the money goes in and we do a lot more experiments. So,
Right, we gotta buy the supplies to do the experiment. So buy one of these excellent things, and then you can reproduce some of the experiments at home too.
right on, man. Yeah. With that said, man, I want to say thank you to everybody out there, man, for watching us today. I really do appreciate it.
And Sean and Chris for making our day with the unboxings, the microscope, and the
Absolutely.
orgonite.
That's
Yeah,
awesome.
we can't thank you guys enough for that. Be some awesome videos on that stuff coming up too. So our channel's gonna explode, Joe. You know what I
Oh
mean?
yeah, man. It's
This
coming.
month. Yeah.
It's coming.
So that, and we, just shout out Mike Faraday real quick. He's got a show coming up here in a little bit, and he's also going to help us out there with the with his Renegade device. So, and then we're doing the Bedini SG, man. We got a lot of stuff going. So, and then we'll be on. I'll be on Traveling Fools later tonight. So don't miss out on that. We have a guy over there who's doing a UFO conference, and we're going to be asking him 50 million questions. So see how that goes. With that said, man, what do you got? Anything else, Bernie?
I'm just showing the little coil capacitor thing that I got here. Nathan tried it out, and he's like, "Oh my god, you can feel the electromagnetic field through your hand as you're spinning, and it's true electrical engineering and physics that you're actually making the field and moving the energy around."
I have
So,
that same
we're gonna be
experience
doing
all the time,
I'm gonna
man.
be
It's
doing a
very
lot of wire stripping and wire coiling over the next few weeks, let me tell you. So, yeah, stay tuned for it all.
You want to know something? Every time I try to show something unsuccessfully with these rocks, and I'm like, oh yeah, I'm going to try to show you, but it's because of the same exact thing that Bernie was just saying and what you said you experienced there. That's exactly what you get out of what I'm doing, and I'm like, I could tell, but like I know it's not translating to anything for you. It's what it
Well,
is.
check it
But-
out. It put it under my hand and felt it right through my hand.
That's exactly the effect. You could feel it. It's
Yeah.
strong. Yeah, but anyway, with that said, everybody have a good weekend. Peace and love.
Right on, brother. Thank you very much, everybody.
The old man will. The old man will. The old man will. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. 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 Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.